We don't always have an intuitive interpretation of our findings in mediation analysis using the original metrics of the variables. So sometimes it's beneficial to report effect size measures for the indirect effect. First, we'll see what are some reasons we may opt for reporting effect size measures for the indirect effect, in addition to findings regarding whether the indirect effect is significantly different from zero. There are different effect size measures in mediation analysis, different ways of thinking about the magnitude of the indirect effect, as we'll see. So then we'll conclude the lecture with interpretations of effect size measures for the indirect effect, and we'll see how we can compute various effect size measures for the indirect effect using R. Here's our dataset that we used in the previous couple of lectures. Here we're estimating the indirect effect of being a college athlete on GPA through number of drinks consumed when drinking in a social setting. So as we know, the point estimate of the mediated effect in this model is equal to negative 0.017, and GPA, our outcome variable, is on a 9-point scale. So this value of negative 0.017 is in units of GPA. In other words, it is the change in GPA for a 1 unit increase in athlete transmitted through number of drinks consumed in a social setting. Now, this 9-point GPA scale is not very intuitive. We see here that the indirect effect ends up being less than 1 unit. However, it's not a metric that's very straightforward for judging if this is a small, medium, or large effect. We know that this effect is statistically significant, but we also know that we have a very large sample size. We have over 9,000 individuals in the data set. So it would be useful to examine the magnitude of this indirect effect using effect size measures for the mediated effect. The use of effect size measures instead of sole reliance on significance tests is not unique to mediation analysis. So there has been a trend in the last decade towards using confidence intervals instead of just point estimates and reporting effect size measures instead of just results of hypothesis testing. This has been happening because statistical significance does not guarantee practical or clinical significance. This is especially difficult to judge when we have an outcome measure that is on a scale that's not intuitive to us. So for example, if we have an outcome measure that's measured in minutes, anybody can understand what a change due to the mediated effect that is in the amount of 5 minutes means. However, if we have points on a Likert scale or a scale like the 9-point GPA scale in this example, it may not be as straightforward to interpret if this is a large indirect effect or if it's negligible. So in order to judge the practical meaning of a significant indirect effect, there are different effect size measures we can compute for it. The first one is referred to as the partially standardized mediated effect. It is equal to the raw value of the indirect effect divided by the standard deviation of the outcome. So in this case, for a 1 unit increase in athlete, in other words, by being a college athlete versus not being a college athlete, GPA decreased by 0.009 standard deviations through changes in the number of drinks consumed. This might remind you a little bit of Cohen's d. So be careful because we don't use the same cutoff values for what's small, medium, and large, but thinking in terms of standard deviation is more familiar to us. So for example, this decrease of 0.009 standard deviations seems fairly negligible, even though we concluded that this indirect effect is statistically significant. So if we're trying to design an intervention and we find an effect size measure that is this small for the indirect effect, we may not bother implementing this intervention because a significant indirect effect doesn't seem to yield any practical significance. We also have the fully standardized mediated effect. It is equal to the indirect effect times the standard deviation of the independent variable divided by the standard deviation of the outcome. It's interpreted as the change in standard deviations of the outcome due to a 1 standard deviation increase in the independent variable through changes in the mediator. So here we see that by being a college athlete versus not, so here for 1 standard deviation increase in athlete, GPA decreased by 0.003 standard deviations through changes in the number of drinks. Is this more intuitive than the partially standardized mediated effect? Not really when our X is binary, but we'll talk more about it later. We also have the proportion mediated, which is equal to the indirect effect divided by the total effect. The total effect is equal to the indirect plus the direct effect in the single mediator model. And for these data, the indirect effect and the direct effect are of the same sign. So this is a meaningful effect size measure to report. So here we find that the mediated effect of being an athlete on GPA through the number of drinks consumed is equal to 7.1% of the total effect of being an athlete on GPA. So in other words, the effect of being an athlete on GPA is transmitted indirectly, but only 7.1% of it is. The remainder of the effect of being an athlete on GPA is transmitted directly. We also have the ratio mediated, which is the ratio of the indirect effect to the direct effect. This tells us the relative magnitude of the indirect effect and the direct effect. So here, for example, in these data, the ratio of the mediated effect of being an athlete to the direct effect of being an athlete on GPA is equal to 0.076. So in other words, the mediated effect is only 7.6% of the magnitude of the direct effect. So it's several times smaller than the direct effect in these data. Now, in linear regression analysis, we often report the R-squared as a measure of fit for the entire model. So we have a mediation version of R-squared measures. However, there are several possibilities for computing an R-squared for the indirect effect. So the first definition of an R-squared value for the mediated effect is the amount of variance in Y in our outcome that is explained by M specific to the mediated effect. Then we also have what we're going to refer to as equation 4.6. So these are equations in chapter 4 of the book by McKinnon, published in 2008. So these are 3 different R-squared values you'll see for the indirect effect in the literature. So equation 4.6 computes the R-squared for the indirect effect as the product of the squared correlation between X and M times the squared partial correlation between M and Y, partialed for the effect of X. And then we have a third definition, which is the proportion of variation in Y explained by the mediation model due to the product of squared correlations between X and M and Y partialing out X. So here, the goal of this indirect effect R-squared is to capture the variation in Y that's accounted for by the indirect effect, and that's not explained by the direct effect. But notice that there's different ways of thinking about it and different ways of computing this effect size measure. So equation 4.5 seems to have the most intuitive interpretation, but just keep in mind that there are different ways of conceptualizing the amount of variance in Y explained by the indirect effect. So for these data, the first R-squared value from equation 4.5 tells us that 0.0003 is the amount of variance in GPA that is explained by the number of drinks specific to the mediated effect. So here we see that less than 1% of variance in GPA is explained by number of drinks specific to the mediated effect. When we move on to R squared based on equation 4.6, we again see less than 1% of variance in GPA is accounted for by the product of the squared correlation between being an athlete and number of alcoholic drinks, and the squared partial correlation between number of alcoholic drinks and GPA, partial for the effect of being an athlete. Finally, R squared based on equation 4.7 tells us that 0.1% is the proportion of variation in GPA explained by the mediation model due to the product of squared correlations between being an athlete and number of alcoholic drinks and the number of alcoholic drinks in GPA, partially out being an athlete. So even though these three R squared values are defined differently, all of them suggest that the amount of variance in the outcome due to the indirect effect, however it is computed, is quite negligible. In every case, it is well below 1%. Now, in addition to the interpretation of a given effect size measure, there has also been a literature examining the statistical properties of different effect size measures for the indirect effect and the required sample sizes we need for these estimates to stabilize. So, for example, we know that we need at least 500 observations in our data set for accurate point and variance estimates of the proportion mediated. The ratio mediated requires an even larger sample size to stabilize, so we need at least 2,000 observations when all variables are continuous, x, m, and y. R squared measures seem to have satisfactory statistical properties with sample sizes as low as 100. And the same is true for the partially and fully standardized indirect effects. So these effect size measures tend to have lower bias and more stability than the proportion and the ratio mediated. So here we see that if you have a small sample size, you may prefer to report R squared measures and the standardized effect size measures because those estimates will be more accurate for small sample sizes. On the other hand, if you have a large sample, you can select any effect size measure you'd like because the statistical properties will be satisfactory, and your main criterion can be the interpretation of that effect size measure. In addition to statistical properties, we need to keep in mind what does our effect size measure mean for the variables we have in the model. So as we saw here, we have a binary independent variable. So this 1 unit increase in x is actually quite meaningful in this case because a 1 unit increase in x means the difference between being a college athlete and not being a college athlete. Whereas if we were to report the fully standardized indirect effect, we have an interpretation in terms of increases in standard deviations of the independent variable, which doesn't make much sense for a binary x. So the partially standardized indirect effect is preferred over the fully standardized indirect effect when we have a binary independent variable. Another consideration is which effect size measure is best suited for answering our research question. So are we trying to compute the amount of variance in the outcome explained by the indirect effect, or capture the change in the dependent variable through the mediator in standard deviations, or is our research question more about the relative magnitude of the indirect effect and the direct effect? So all of those research questions will favor a different effect size measure. And finally, an important consideration when selecting either the proportion mediated or the ratio mediated is whether our indirect effect and our direct effect are of the same sign. If the indirect effect and the direct effect cancel each other out, the proportion mediated may end up being greater than 1, which doesn't make sense. And also, we may end up with a negative ratio mediated if the indirect and the direct effect are of opposite signs. So all of these are important things to keep in mind when selecting an effect size measure for the indirect effect. Now, going back to our previous output from MBES, where we looked at the confidence intervals for the indirect effect obtained using the percentile bootstrap, we see that MBESS reports some additional output. So here, when we look in the column estimate, we see values for indirect effect, partially standardized. So here, this is our indirect effect divided by the standard deviation of y. So here again, we will round our estimate of the partially standardized indirect effect to 3 decimal places. Okay, and then we get our value of negative 0.009 standard deviations of GPA for a 1 unit increase in being a college athlete through changes in number of drinks consumed. This value for index of mediation refers to the fully standardized indirect effect. So here's our value for the indirect effect AB times the standard deviation of X divided by the standard deviation of Y. This is the effect size measure that isn't quite suitable for this example because we have a binary independent variable and it's more intuitive to think of a 1 unit increase instead of a 1 standard deviation increase. Next, we have our R-squared values based on equations 4.5, 4.6, and 4.7. Then we have the ratio of the indirect effect to the total effect. So this is AB divided by the sum AB plus C prime. In this case, it makes sense to examine the proportion mediated because we have a large sample size. And we have an indirect effect and a direct effect that are of the same sign. In some examples, this won't make sense as an effect size measure if we have indirect and direct effects of opposite signs. And finally, we have the ratio of indirect to direct effect. That's our ratio mediated. So here, we'll see the same value we saw on the slide. So the ratio of the indirect to the direct effect is 0.076. So as we saw, the indirect effect is only 7.6% of the magnitude of the direct effect. So by default, the mediation function in MBESS also prints out these effect size measures. And if your research question involves questions about whether the standardized indirect effect is significantly greater than 0, notice that we also get bootstrap confidence intervals for each one of these effect size measures. So here we see that for each one of our effect size measures, we have intervals that would suggest that they're significantly different from 0 because none of the intervals include 0. However, remember that evaluations of effect size measures are done in order to examine whether the effect is clinically significant. And the magnitudes of these effect size measures we saw for these data don't really suggest that we have a practically significant indirect effect, even though it's significantly different from 0.